the previous videos, we took a look at how to use the equation of the regression line once we found it. So we looked at making predictions if you choose values of x that are in and among the points you have, and that was interpolation, versus if you chose values of x that are way away from your points, and that's extrapolation. Now that we've looked at how to kind of use that equation, I want to take a step back and look at where this equation comes from. So in this class, all of our regression lines that we're using are in fact straight lines. But if you took a more advanced class, you could certainly fit all kinds of curves to data sets as well. So a regression line is a straight line that describes how the response variable y changes as the explanatory variable x changes. So with our ice cream sales example, every time the temperature went up 1 degree, the ice cream sales increased by $33. Okay, and so that's kind of how those two are changing together. The regression line summarizes the relationship or pattern between two variables, but only if one of the variables helps explain or predict the other. So you do need some sort of explanatory process going on there, or cause and effect, or something of that sort for this to be a useful process. And then a linear regression line also has a constant rate of change. So it's going to increase by the same amount each time or decrease by the same amount each time. All right, so that equation is y is equal to mx plus b. And so x and y are going to be our two variables. X is our explanatory and y is our response variable. And then our slope and intercept are going to be fixed numbers that come about through our data. So that slope is telling us whether we're going uphill or downhill and how steep we are. And then that intercept is where we're crossing the y-axis. And we'll take a look at that in a little more detail in just a minute. But before we do that, the type of line we're using is called a least squares regression line. And to explain how this line kind of comes about and works, we have to define a new term, and that term is the residual. So if we took our data point and we drew a vertical line straight up or down from our point to the line, that distance is called a residual. So if the dot is above the line, that residual will be positive, and if it's below the line, it'll be negative. So what the least squares regression line does is it takes each of those residuals and it squares them, and then it adds them all up. And what they're looking for is the placement of the line that gives the smallest total value. Okay, so that's going to look like this picture here. So you'll see that we have a point A. So there's our residual. If you look at A going straight down to the line, and then you'll notice that they turned it into a square. So that's that squared idea. And they did that for every single point that's on there. And so they get an area for all those squares and they add them up. And the idea is that you're putting the line in the spot that makes that total area the smallest possible. So that's where we're getting the least from, and then that's where we're also getting the squares from in the name of that. Okay. All right, so we do have an app that we can take a look at, and we're going to experiment with placing that line at best fit on there and see how good of a job we do just eyeballing it. So there is a link on the PowerPoint slide, as well as if you are in the class and following along on Canvas, there's a link there. And so give me just a second and we'll pop over and take a look at that here. All right, so this is where that link takes you. And so I'm going to choose a data set from here. There's a bunch of different data sets, and you're welcome to choose whatever you like. I've been through these before, so I'm going to choose this spending and salaries one. It's a nice one. On the right side of the screen, it says my line, and you'll see it says y equals 0x plus 0. And then they have some sliders here. So I can change the slope of the line. Right now it's just flat, so I can change it to be uphill. Or I can change it to be downhill, and I'll show you that in just a second. I can also adjust the intercept. So here I'm changing kind of the starting point for the line, and so now I can make this negative, or I can change it back to positive. So what I'd like you to do is play around with this, see if you can figure out where you think that best line is. So here I have an uphill line going through there. Maybe I need to make it a little steeper. Okay, so that looks pretty good. So I can put the residuals on there, so it'll show me the residuals. And so, you know, as you move it, you can see, okay, that's getting a lot worse, or a lot better. You can also put the squared residuals on there, so you can see the total area. And it puts a little bar at the bottom here, so you can see how the area changes as you adjust the sliders. So you can try and find the best fit on there. And once you've kind of played around with that a little bit, you can go over to the left side where it says best fit line. There's a plus sign there. You can click the best fit line and actually see how close your line is to theirs. So mine's not too terribly bad off, but we can look at the residuals for their line. Yeah, you can see that is a little bit smaller and a little bit better. As well as it'll tell you the correlation coefficient. So this is just, I'll give you some fun practice to try a couple of these out and just see how you do fitting those lines in there and how closely that works out.